What if the power that fuels your morning coffee, lights up homes, and drives industries wasn't available at your fingertips? Imagine a day without electricity. Unsettling, isn't it? This vivid illustration underscores the importance of energy resources and power systems in our daily lives. Diving into the sea of energy resources, one encounters a vast array of options. From fossil fuels like coal and natural gas, nuclear energy, to renewables such as solar, wind, and hydroelectric power. Each of these resources has its unique advantages and challenges. For instance, while fossil fuels are abundant and easy to extract, they are non-renewable and contribute to environmental degradation. On the other hand, renewables are sustainable and eco-friendly, but their availability is subject to weather and geographical conditions. Institutional arrangements and regulatory affairs play a pivotal role in power systems. They ensure that energy resources are harnessed optimally, power distribution is efficient, and consumers' rights are protected. They shape the energy landscape by setting standards, formulating policies, and enforcing regulations. Now visualize a vast network of overhead lines and cables crisscrossing landscapes. They are the arteries of power systems, transporting electricity from power plants to homes and industries. They consist of main components like line supports and insulators. Insulators, made from materials like porcelain and glass, prevent electricity from leaking to the ground. Types of insulators include pin, suspension, and strain insulators. However, these systems aren't perfect. They suffer from an electrical phenomenon called corona, a luminous glow that results in power loss. Then there are underground cables, a safer and aesthetically pleasing alternative to overhead lines. But they come with their own set of challenges like higher installation costs and complex fault detection. Ever wondered how electricity demand varies throughout the day? That's where load curves come in. They depict the variation of electrical load in a power system over a period, helping grid operators plan and control power generation. Power distribution systems are the unsung heroes, quietly ensuring that electricity reaches every nook and corner of our cities. They comprise primary and secondary distribution systems, each catering to different voltage levels and consumer categories. Scene script. Substations play a crucial role in power systems by transforming voltage levels and facilitating power flow control. They house major equipment like transformers, circuit breakers, and bus bars. The bus bar configurations determine how power is routed within the substation. Every line in the power system has inherent parameters like resistance, conductance, inductance, and capacitance. These parameters, influenced by effects like proximity, skin, and Ferranti, impact the performance of power lines. The per-unit system is another key aspect of power systems. It simplifies the complex calculations involved in power system analysis by normalizing quantities like voltage, current, and impedance. Lastly, earthing techniques are employed to ensure safety in power systems. They prevent electrical shocks by providing a path for the current to flow into the ground in case of a fault. In conclusion, energy resources and power systems are the invisible forces that power our lives. From generation to distribution, every element of a power system plays a vital role in ensuring that the switch in your home always lights up your world. So next time you switch on a device, spare a thought for the intricate and fascinating world of power systems that makes it possible.